Hello everyone, my name is Julio Constantino. I am a graduate student from the University of Texas, Rio Grande Valley, and I am doing my research under the supervision of Dr. Mohammed Abdul Rahim. For this conference, our paper and research efforts deal with tackling the problem of brownfield remediation and prioritization, a common problem that can be found in many urbanized countries around the world, and which can go by several names such as previously developed land, degraded urban areas, derelict lands, etc. The title for my presentation is Towards a More Sustainable Approach to Evaluate Brownfields for paper number 580. The outline for this presentation consists of the following. We're going to have an introduction to brownfields. We're going to talk about the problem statement. We're going to go over the problem with brownfield contaminants. We're going to go over how we are going to prioritize our sites. We're going to talk about the decision support system that we will be using to tackle this problem, the criteria that will be used to assess the brownfields, future work, conclusion, contact information, and also references that were used for this presentation. According to the US EPA, brownfields are any parcel of land, property, or industrial sites with current or derelict conditions that have accumulated over their operational life cycles unsafe amounts of contaminants and waste. It is estimated that there are more than 450,000 brownfield site locations in the US alone, and cleaning up and reinvesting in these properties can help out communities and can help out the area around it, such as increasing local tax bases, facilitate job growth. It utilizes existing infrastructures, takes development pressures of undeveloped open land, and improves and protects the surrounding environment. The problem with brownfields is that there are environmental contaminants which can affect the quality of the surrounding water, soil, and air in its nearby communities, thereby having a negative effect on the quality of life for the people near the site. In order to treat brownfield contaminants, we have various remediation technologies that are available. Remediation efforts for these technologies can require significant amounts of money, resources, and time to effectively treat the site. Some examples of these technologies may include bioremediation, air sparging, soil vapor extraction, permeable reactive barriers, or the usage of biological methods. The remediation technologies change based on contaminant types, and there is no one solution for every problem. This is especially true when dealing with sites that have contaminant combinations. So, the objective for us then is to remediate the brownfields that will maximize the impact on our society, our environment, and on our economy. So, how can we prioritize these brownfield sites? There are many factors such as money, cost, resources, environmental remediation, technologies that are available. Ultimately, this involves weighing different factors and criteria that can be used to make an informed decision, that is, involving choosing the most impactful brownfield site. In order to do this, we have to come up with a comprehensive, organized method that will capture all the objectives, criteria, and attributes in order to have a comprehensive scientific evaluation for the impact of remediating any brownfield based on the core concepts of sustainability. Now, in order to do that, we propose a multi-level decision support system, which will have our brownfield input that will consist of objectives of environmental, economic, and society, and each of the objectives will have its own criteria, and each criteria will have its own attribute. Overall, all of this information will help us gather the brownfield priority of the site. Now, in order for us to have a meaningful comparison, we need a tool to conduct pairwise comparison, which in this research, we adopted the analytical hierarchy process. We are going to combine this hierarchy with the AHP in a user-friendly software that will present a tool to the experts to help them prioritize the remediation of brownfields on present criteria. This tool will also allow experts to change weights based on project direction or project needs. Now, the inherent advantages of using this system is that the costs are set aside so that the benefits of the alternatives are properly evaluated. It is a practical tool used for evaluation, and it can provide an overall view of the complex relationships of sustainability in brownfields. As you can see on the figure we have on the right, whereby we have our objectives, criteria, and attributes for the decision support in brownfields remediation and land recycling. The criteria for the environmental objective consist of the following. It consists of 5 significant environmental criteria and 12 varying attributes, which include reclamation of surface and groundwater quality, which includes subsurface and groundwater treatment required for the brownfield site, habitat restoration, whereby we will restore the physical, chemical, and biological functions of the site, protection of soil health, which we're going to enhance and restore soils through human and natural processes, surrounding environmental impact, whereby we take into consideration the local benefits of remediation, and the preservation of site ecological value, whereby wildlife biodiversity and allocation of resources will be given towards conservation. Now, for the economic objective, the criteria consist of 6 economic criteria and 12 varying attributes, which include location and linkage, whereby we increase the site's economic impact on the community with essential services and community support, site diagnostic, whereby the investigation and testing efforts are required to determine the contaminants on the site, such as through the usage of in situ and ex situ diagnostics, methods required, whereby the remediation cost and time are considered based on existing technologies and contaminant mitigation on the site, industrial ecology, whereby the byproducts of remediation are identified and cost-effective disposal is implemented, economic prosperity, the goals of the community and the goals of businesses are considered, and need is fulfilled with a depletion of unnecessary resources, and finally, capital investment, whereby the funds available and money invested for the project is included in this decision from previous funded efforts and improvements. Now, for the society objective, this consists of 5 societal criteria and 12 varying attributes, which include sustainable designs, whereby the decision maker considers the best functions and uses of the site location, enhancement of public health and safety, whereby the project can meet the safety regulations for operations and can enhance the protection of community health, enhancement of public view and local character, whereby we are enhancing and creating significant visual impacts on the community through improvement and remodeling of the site, increase of mobility, whereby we are promoting alternative transportation practices and connectivity is implemented in the design, and long-term monitoring and maintenance, whereby we're enhancing performance and minimizing the cost of the social, environmental, and economic impacts of ongoing maintenance for the site. The application of this decision support tool within the realm of brownfield remediation and land recycling allows the decision maker to base their decisions under both a reliable and a standard approach tool that has been used within various industries and that has various realms of applications. Some of the future work for this research includes sending out a survey to the experts that will be used for the gathering of data for the decision support tool. Apart from that, an Excel tool will be created for the decision maker in order to assess his or her decision based on professional weights or personal preference based on their project direction. And aside from that, we of course are going to be doing journal publishing. Now, an attempt has been made in this research to critically evaluate the brownfields using sustainable decision objectives and criteria by implementing lead and envision core concepts to the prioritization of brownfield sites including, of course, concepts of the triple bottom line, the categories for quality of life, resource allocation. For more information, and if you would like to have a follow-up reply, please go ahead and contact me. Here is my contact information. And if you have any other questions, send me an email. And here I am. Thank you very much. Thank you for your time.